To understand the chain rule, we have to be reminded of what a composite function is. So, a composite function is when one function gets plugged into another function. For instance, cos of 3x can be considered a composite function. Since it's a composition of maybe f of x is equal to cosine x, and g of x is equal to 3x, such that you've taken your f of x function and replaced the x with g of x. So this gets plugged into here. When we have these complicated composite functions, we need the chain rule to derive these compositions. And here it is. When you have f of g of x and you're taking the derivative, you take the derivative of f of g of x, and you have to also multiply it by the derivative of that plugged into piece, the derivative of g of x as well. For example, if we go back to our cos 3x and we want to find the first derivative, we think about our f of x being cos x and our other function g of x being 3x. And so to find the derivative, I take the derivative of cos x, which is negative sine, but I use 3x in the place, and I multiply it by the derivative of the inside part, which is 3, to get negative 3 sine 3x. So this piece is f prime of g of x, and this piece is g prime of x. Take a look at another example. Finding the derivative of this function is very much like the composition of the square root of x, but g of x is the inside part, x squared minus 2x minus 1. So to do square root functions, we think about them as functions to the power of 1/2. When I take the derivative of this, I bring down the 1/2. I keep this part. I drop the exponent by 1, and I multiply by the derivative of the inside part, which is your g of x derivative, and that would be 2x minus 2. 2x minus 2 times 1/2 will give you x minus 1 times x squared minus 2x minus 1 to the negative 1/2. And here's one more very complicated example. Okay, this one's quite difficult because we need to think about a composition with 3 functions, a function put inside a function put inside a function, double plugging in. So y is the same, cotan to the power of 7 is really thinking about cotan of x to the 5, all of that raised to the 7th power. That's why you can think about your original function as something raised to the 7th power. Then what's plugged into that is a cotan of x, and then what's plugged into that is x becomes x to the 5th. So we need to do this through that idea of a chain. So the first thing I take the derivative of is my f of x, so I get 7, but x isn't x, it's cotan x to the 5 to the power of 6. Then the chain rule kicks in, and I need to take the derivative of the inside part and multiply it. The derivative of a cotan is negative cosecant squared x, but in this case it's x to the power of 5, and I still need to take the derivative of the plugged in part for that, which is 5x to the power of 4. That gives me 35 x to the power of 4, negative 35 x to the power of 4, cotan to the 6, x to the 5, and cosecant squared of x to the 5. So once again, I start off with my f of x being x to the power of 7. Then I plugged in, it's not x to the power of 7, it's cotan x to the power of 7. So my function now is a bit more complicated. It's cotan x all to the power of 7, which is the same as cotan 7x, and then I plug this in for x, and so now I've got f of g of h of x, and that's equal to cotan 7x to the 5. It looks simple to start with, kind of, but the derivative becomes quite difficult as you need to chain through. What's the original function? What's it composed of? What's it composed of? Etc. So sometimes the chain has 2 pieces, sometimes it has 3, sometimes it has quite a few pieces. Alright, enjoy the homework.